This one's pretty easy to evaluate if you know how to evaluate an integral visually. But our textbook has asked that we use the antiderivative. So the antiderivative approach to evaluating an integral means that you want to think of a function whose derivative equals 8. Whatever function that is, that's called your antiderivative. So if we take a derivative of 8 right now, it would make 0. So it's not itself for the antiderivative. If we take a derivative of x squared, we know the 2 comes down and multiplies, and then the power gets reduced by 1. So x squared, in other words, is the antiderivative to 2x. Okay. So the antiderivative of a constant, you just need to add an x on there, because when you take a derivative of 8x, the 1 comes down and multiplies, so it doesn't change your constant, and then the power gets reduced by 1. So that makes just 8. Okay, so the antiderivative of 8 is 8x. And so once you have your antiderivative, go ahead and write it down, but then you need to evaluate your limits of integration. And what that means is you need to plug in 7 into your antiderivative, and then subtract what happens when you plug in 3 into your antiderivative. So that's 56 minus 24, so that's 32 if I did everything right there.